This is Peter Rutter from VFE Pedals, and this is going to be a walkthrough video of how to assemble that beast, the Klein Bottle. I'm going to go through the different kind of documentation that's available for you, as well as just some tips on how to assemble it without running into issues. This is definitely not a build for beginners by no means, and so I don't recommend that if this is your first build. It's a challenge. As you can see, here's an assembled circuit board. There are a lot of parts and a lot of solder joints, and that's, this is just a circuit board, let alone when you go to install it, some of the challenges there. So I'm going to try to walk you through all this, but again, I'm assuming that you know kind of the basics of assembly, so I'm not going to go over those things. So anyway, if you got just the circuit board, you would have gotten a box like this, and inside should be all the dual gang pots. So there should be 7 of those, 6 of the ones that are C100K on this side and C10K on that side. And you also will get a circuit board, and on this circuit board there should be, I believe, 8 chips installed. So there's 3 quad op amps here, and then 2 dual op amps, if I remember correctly. These two, they're really hard to read, but these should be the I believe OPA 1602, and these are 1604 super low noise op amps, and then these 1, 2, 3 are the switching microcontrollers, and that should be all that is installed already, surface mount. If you don't have all 8 of these chips on your board, please let me know. That's this kit. If you got the next level up, it basically includes all of those parts plus the case that's been pre-drilled. And then if you got the bare bones kit, that's this one here. Should come with all the wires. We'll get to that later. This is actually one I'm going to walk through because it's got the whole rest of it. Plus, when you open it up here and you pull this out, it should have a printed graphic and all the larger parts in here. Now, the parts that are not included, and I'll go over this a little bit more, but basically anything that's going to go into this circuit board, any through-hole component going into this side of the circuit board is not included. There's a master parts list that. For the reason for that is really simple. If you wanted me to sort all these parts out, they'd be in one giant bag, and I'd have to charge you more because of all the time, because I'm not a massive distributor. I don't have all the systems to make those kind of sorting things really fast. So you would get one jumbled bag of things, and you'd have to read it would just be a nightmare. And I'd have to charge you more because of the slower process. So rather than doing that, I've created a master list. I've sent that out. If you didn't get it, please let me know. And you can download those parts, order those parts and have them come in actual separate baggies and make it easier to build. All right, anyway, let's go ahead and get on to the actual building. Oh, one thing to note. So for the sake of clarity, I have put on all of because I printed the same graphic, as you can see, for things that I built as VFE pedals and things that you built, so that you are getting a final product that looks the part. But I wanted to make sure it's obvious who built it. And so this one says VFE DIY pedal kit on it. All the ones that you would build rather than me say DIY pedal kit on them, whereas this one says made by VFE pedals. So if you see, if you happen to be on the used market at some point and you see DIY pedal kit, you'll know that was assembled by someone else, not by me. Anyway, I just wanted there to be some clarity on that. I'm going to actually set this DIY one aside. I'm going to actually use this one because I'm building it. So here we go. Let's go ahead and get started. So first thing, you're going to want to get the bill of materials, which that file will have a list of parts like this. It'll be 3 pages long. So the first 2 pages are all the parts that go on the circuit board. Basically all the parts that you see here on top are on these 2 pages. The ones listed in purple, so down here and here, are the ones that should be pre-installed and soldered surface mount style. All the ones in black are the ones that you would need to source yourself. Now, it's important to mention that, like, obviously I've listed a specific part number, but there are other companies that sell an equivalent resistor, and it's totally fine. It's just that this is the one that I use. This is the one that is for the specs of this. So there are other ones that'll work, but you know, it's a little bit of more work to figure that out. In the PDF document that this is printed from, every single one of these things is linked, so you can click on it. It'll go directly to a link where it can be purchased. So that's these first 2 pages. The last 2 pages contains parts that aren't seen here. They're actually the parts that are included in the bare metal. So that includes things like, the bare bones one includes things like switches, jacks, and such. They're a little bit different because some of these things were custom made, or some of them they're easy substitutions by another brand. It's a little easier to substitute, I should say, and they're also sometimes harder to source. So I wanted to give you 4 different places to potentially source them from if you were going to do them. So the 1790 NS enclosure, which is included unless it's the $49 TIOI kit. But if you need to buy that, there's some links to an equivalent one, the 1590 XX. I should update that because I believe, oh wait, no, if you want to get the 1790 NS, exactly, I think that's Pedal Parts Plus is where you'll need to go for that. But the 1590 XX is also, it's so close in dimensions that you can use it. I think it's actually slightly bigger, so not a problem. And so here's an example, like these Vimex pots that I bought, they were custom ordered for this thing, so you can see some different, but it doesn't mean that, you know, there are other B10K pots out there, and I have a D1M, which is a 10% logarithmic taper, whereas an A1M, which is easy to find, is a 15%. So this will work. It's not the one that I use, but it's totally going to work. It's not a big deal to go ahead and use that. And so on. So, and I even, you know, links for dust caps and all that kind of stuff, and we'll get to that in a moment. All right. Okay, so here's how it's going to work. When we're going to get started is that, save all that rest of that stuff. We're going to start just with these first 2 pages. So what I would do, and I'm not going to do that in this video because it would take a really long time to show you that. Plus, the assumption is that you are, that this isn't your first time, and so this is something you can follow along. So here it says I have a 100 watt resistor, sorry, 100 ohm resistor, 8th watt. And then it tells me all the part numbers. There's 13 of them, and the part numbers are R1, R3, R5. What that does, it makes it really easy. You can see there's a ton of resistors, but now it's really easy to find them because R1 is right here in the top left, and as you read across, you get all the way to R7 here, and then it sort of restarts in between these two. Basically, the potentiometers become my boundary. So between these two, you can see a kind of a row of parts there. See if I can point more clearly. And so now there's R8, so R7's there. Now we're at R8, and we keep going across, and it looks like R10 is there. And then this whole section is kind of like its own sort of thing. So I have R11, R12, R13, 14, 15, 16. And so I'm going through this section up above the chips, and then below the chips, but above these potentiometers. And so there's a flow to it. I'm not going to go through the whole flow, but you can kind of, should be able to find the parts rather quickly rather than searching aimlessly forever. That's the reason why I'm doing part numbers rather than the actual values, rather than actually writing 100 here, because then you'd have take forever to figure out where stuff are. So that's how that works. So if I'm looking to find out where to put this part number, I go, oh, R35, R37, R38, and I go and find those on the board and I put it in there. So As for the order, generally speaking, like I put it in an order that's was a little bit easier for like ordering, but also for because categorically they go together, but also for assembly. So on this side are parts that are axial, which means, in case you don't know what that word means, like this, parts that come out like they're on a axis here, or an axle, like they can spin. Anyway, it's axial, and so that's what all these parts are. And so they're really, they're not high profile. They're all the small parts. You want to put those in first. Makes it a lot easier to do that, because if you put in all these big parts and then try to somehow stuff in all these tiny parts, it becomes really cumbersome. All right, moving on to the back side, you can see here's some of the surface mount stuff, and then moving forward, there's all these chips. The only thing that where there's anything that's somewhat taller than other things is that there's this IC, which is a voltage regulator, which is right here, which is taller than some of the other parts that come after it, but I put it here because it's part of the IC part number section. However, that one's in a place where it's not going to obstruct anything. So just basically, you can just follow this list, put these part, this part, this part, this part, just go in order, this part, you know, all the way down. And all along the way, clipping off the leads. Okay, anyway, so there you go. So that's how you do that. So I'm going to basically go from this to this, and then, of course, you're going to solder that, and that is not something I'm going to teach you how to do. Just make sure you don't solder anything that doesn't have a part in it, because we're going to need to use those holes on the next step. All right, now, the next step is basically we're going to prepare the enclosure and then get this ready to go. And to do that, I'm going to use all the parts from the bare bone kit. Okay, so I'm going to pull this out, and the parts that I'm going to put in right now are all the potentiometers and toggle switches, as well as the LED lights. So any potentiometers, toggle switches, or LED lights. In the enclosure, I'm going to put the foot switches, which this one already has in, and of course this one goes to that DIY one over there. But this one already has in. I should note, one, you want their foot switches. You want these tight. You don't want them loose. That would be, at the very least, annoying, and at the very worst, you know, potentially damaging. Anyway, this is the orientation you want. You want the outer two facing in, and then this middle one, as you look this way, would be facing to the left. That'll help all the solder, where it has to solder into the board much closer, make it easier with the wires that are there. And so that's all you need to do is put those, to prep the enclosures, put those foot switches in. Now to prep this, we're going to stick in all the potentiometers and toggle switches. So let's start with these 9mm ones. There's one of them that is a C100K, and the other seven are A10Ks. So there we go, C100K, I find that one first. Okay, I'm going to stick it here. That's where, and you can always see it printed on the other side. It says C100K there. And I'm going to take a little plier here, and I'm going to slightly, I'm not going to like totally slam it down, but slightly pull those ajar, so it's got some wiggle to it if I really push on it, but it's also not it's not really loose either. Okay, and now I'm going to go ahead and put in all the A10Ks and do the same process for each of those. So just a little bit of bend on each of those. The reason why we don't totally fold them down is because, as with anything built like hand like this, there are some tolerance issues. Also, while I'm doing this, I do want to note that there are some parts of this circuit board where the legs on the other side, you need to really pay attention to their height, and I will explain that in just a second. Basically, you know, we're putting parts on this side, and we don't want the legs sticking up super high in some areas, because that'll get things kind of off, and they won't sit flush, and it'll make for a really awkward build at the very least, and at the worst, it will not work, or create shorts or breakage, or, you know, make it prone to have like too much tension on it and break eventually. Okay, so I've got those ones in. Next thing I'm going to do is I'm going to do all of the dual gang pots. Now, the dual gang pots are going to go all along the top row. The one you'll see there's the C10K, C100K, and then there's one that's different, and it says B10K on both sides. That one has a little tab that we're going to need to snap off. It's the only potentiometer like that, because it wasn't, it was an off-the-shelf part. It wasn't a custom designed, custom order for this. So anyway, I strongly recommend taking these front outer two legs and pulling them a little bit apart. Not so hard that you're really putting a lot of tension, but enough so that when I stick it in here, I can kind of slightly sort of push it in, and it's, because they were pulled apart, it's now giving this pressure, and this part is not really wobbly or sliding around, which makes it a lot easier when I go to install it later. Now this nut and washer I want to pay attention to. It's different than all the other nuts and washers, so I'm going to set it aside in its spot. And then all the other ones, they are identical. You'll notice that on these ones, they will hang off the edge of the board. That is totally fine. That's part of the design. It's part of maximizing some of the space, as you'll see when we actually do some final installation of jacks and such, that the circuit board can't keep going, or else there won't be enough space for everything else, and so it kind of ends there, but it's fine. Okay. All right, and then these other ones, the single gang ones, there's two values. There's D1M, or A1M if you source them yourself, and then B10K. So the D1M is for the pre-control. So if you can see that, the pre's on the right, the mix is on the left. You can also, and I'm not going to flip it over right now, but that is also printed on the other side of the circuit board. So I'm going to do B10K on the ones on the left side here. So it's basically B10K, D1M, B10K, D1M, B10K, D1M, all the way down. So I'm going along here. I'm almost done here. And you'll find with these Vimex that the single gang, because there's fewer legs here, there's going to be a little bit more wiggle to them. It's very important that all these these single gang ones have a dust cap. So you see this plastic dust cap. If you didn't get the bare bone kit, you will want to either get dust caps like this, which they are linked up on the part sheet, or, the other option is just to put a couple of layers of electrical tape on the bottom. It won't hold out the dust, but you do need something there to insulate the bottom of this potentiometer, which is metal, and all of these things. So if you just buy a potentiometer and stick it in like there and don't put any sort of something to insulate it, it'll short out the whole circuit. It won't work at all. So make sure you do that. Let's stick in the last couple ones, B10K and D1M. All right, so there's that. Next, I've got toggle switches. So there are basically two types, and it's pretty obvious which ones are which. What's nice is that there isn't any sort of orientation that's the right way, other than it fits in easily. So you could put it in this way or this way, and it would be the same electrically. Same thing with the smaller toggle switch. This smaller toggle switch right here, it's going to go up there, but then the bigger three ones are all down on this bottom row. Okay, and so there we go. Now, the part that you're going to need to source on your own, unless you responded and had me add it in as an extra, is the LED. I didn't include an LED because I wanted you to be able to customize it however you wanted. So LEDs and knobs I didn't include unless you opted for that extra package. Anyway, it's going to require a 3mm LED. I'm going to go grab, because they're not part of this kit, I'm going to grab them from my shop here. All right, got them. Okay, LEDs are going to have, and 3 millimeters, very important. If you get 5 millimeters, it's not really going to fit in the spot that we're going to put it, or else it'll be, pretty much impossible. So there's a longer leg, shorter leg. The longer leg goes in the square hole, and the shorter leg in the octagon. So square hole, long leg, which is a pretty common practice across all electronics. In fact, you'll see that with the polarized capacitors, that there will be the square one is for the positive or the longer leg on the electrolytic capacitor. All right, so there we have it. We've got everything in. I'm going to actually unscrew. I need to unscrew all of the nuts and washers. Make sure again that the nut and washer on this one is unique to it, because it's a different, it's alpha and not Vimex. It wasn't custom ordered because of the quantities. There's only one of it in the whole thing, and it's an off the shelf, like it's available off the shelf. So, well, this is kind of, for me, this is the part of the build that always feels like the most fun, because it's a part where all of these circuit things that I've been doing, the soldering and the setup, and starting to put stuff together. This is the part where it actually starts to look like a pedal when we get to install it into the circuit, into the enclosure. And so this is kind of a fun part. Often for students too who are first learning assembly, sticking all those stuff that they've been doing, which I haven't had any students build something this complex, but sticking it into enclosure is kind of like that. Oh, it's coming together. This is going to be real. It's going to happen. All right, so there we go. As you do it, you just want to see if you can slide it up in. Sometimes, I mean, that one just popped in real easy, but sometimes you might have to, take one of these things and kind of wiggle it around to get stuff like, especially toggle switches or these 9mm pots. If they're not like straight up and down, they can do that. So you're gonna go ahead and put all back those washers and nuts. I do want to say that I plan to cut out this part here, but I do want to say a couple of things before I do that. On the potentiometers, the nuts here, they don't really have a top or bottom. With the exception of this one over here, you'll see that one side is totally flat and the other side is curved. You want the side that's totally flat down and the side that has curvature up. So that's the only one that really has like top and bottom out of all of the washers and nuts that I'm going to put on here. Okay, so I've tightened up all the nuts and washers. There's a few sort of things that we need to do to tweak-wise before we start getting to the soldering, and so I wanted to show you those. So first of all, just as a note, all of these potentiometers here, these toggle switches and these foot switches, their primary support structure is the enclosure. So make sure these are really tight. That's their primary support structure. And then they in turn, not these because they're wired in, but all of these up here, in turn provide structure for the circuit board, and with that many potentiometers and switches, it's going to be really rigid. These potentiometers are not mounted to the enclosure, just to the circuit board, but as I said, with all of this other structure there, they're going to be in there real firm. So I wanted to show you kind of how to set it up before we go to solder. So I'm going to turn this over. First thing, I just want to like kind of push this thing down to make sure that it's as far down as possible. And then I'm actually going to specifically pry up this side, and there's a reason for that. So these top ones here, there's no dust cover that really works for those. And even if you had one, we're going to be sticking wires into all these top holes and soldering them. And that solder could melt through dust cover. So we're going to give ourselves a slight air gap by tilting the enclosure. We're going to tilt it up just ever so slightly this way to give ourselves some margin for error. So here's how I'm going to do it. So I'm just going to go here and take whatever tool you've got. We're just going to take it, we're going to kind of tilt it up. And you want to be real gentle about this, because I guarantee you there's going to be someone who does this and poof, they're going to pop it off, and they're going to have to do that entire step we just did all the way over, because there's no way with this many parts, if it pops off, to realign it back. So you want to pull it up so that you've got some air gap there. Okay. The next thing you want to do is you want to take these 9mm potentiometers, and I actually usually take my pliers and kind of squeeze them back in a little bit to give them a little bit more sort of leeway, and I just do it ever so slightly. Again, you don't have to do it this way, but I want to make it as easy to use as possible, and so I ever so slightly do that so I have some play, so I can kind of wiggle these and pull them out just a little bit more than they just kind of default sit in there, and try to even them up as far as like how high one is versus the others, and kind of get it to a nice place where they feel easy to use. And it's never going to be exactly the same all the way across, because it just slight tilts in the circuit board, because they're not mounted to the enclosure. You know, it's never going to be perfect, but you're trying to do that. I'm usually spinning as I do this, because I want to make sure that it's in there in such a way that as it rotates, it doesn't rub against the side. And then the last thing, once you've done all those things, is to get the LEDs in these, push down these holes. But depending on your preference, I don't like them to stick all the way out. I like them to stick just ever so slightly. So I will go in like this, and then I will just take one leg, and usually it's top one for, well, don't worry about it. I just take the top one and just bend it down like so, like that. And then now I'm ready to solder these in. So the next thing I'm going to do, I'm going to solder in everything for the potentiometers and the switches. Everything basically I stuck into the circuit board, and the LEDs as well. One thing that I'm going to do as I go along is I'm going to solder like all of the toggle switch lugs, and then all of these dual gang and all these single gang. And then when it comes to these 9mm, these ones right here, the ones that aren't actually mounted into the enclosure, just the circuit board, there's 5 points of contact. There's these 2 big rings, and then the 3 small ones. The 3 small ones are the actual contact points audio-wise. These are just support. And so I solder in the 2 support ones all the way across, and then I actually go back over and I test each one to make sure, okay, now that the support is in, is it smooth all the way across? Is it rubbing against the enclosure? And if it is, which it's likely not to be if you followed the process, but just in case, there are times that it happens, then you can actually go back in and kind of go, oh, this needs to like shift slightly left or right, and you can heat up one of those support things, and once the solder is heated up, kind of make that bend to bend it into place for easy use. Anyway, so I'm going to solder that up. I'm not going to do that on video. Once I come back, I'm going to talk about the things that I did, or I set up the next soldering thing. In general, I'm not going to, I don't think I'm going to do any soldering in the video. I'm just going to show you the process. All right, be right back. All right, there you have it. I have soldered in all of the dual gang potentiometers. There's 2 rows of solder here. Single gang, there's a single row. Your toggle switches, 1, 2, 3, and then that one up there. And then your 8 9mm pots. And the 9mm pots have 1, 2 support posts, and then 1, 2, 3 the potentiometer connections. And so those are all soldered in. Again, I soldered in the support posts on the 9mm, tested them, turned them around, and then came back and soldered in the rest. And those ones I did last out of everything else, so that the entire support structure was in place before I did those ones. All right, now it's time for the wiring, which is the final phase. So first, it's at this point that you want to put in the power jack. Power jack's got a long leg and a short leg. Long leg is positive, and if you look up in here, see if we can get that, where it says power, there's on the right side it says positive. So I'm going to actually spin my jack so that the right side is positive, and stick that on there. One thing I want to note on this one, definitely want to make sure that this is tightened down. If it's loose, it's going to be a major problem. So if you've got the bare bone kit, it comes with 2 of these power jacks, and this is why. While I haven't had any of these go defective in the field, I have had them, especially for people who are more novices with soldering, you know, heat this up so much that this plastic body melts and then the jack doesn't work. So I wanted to make sure to, in the bare bone kit where the jacks were included, to include 2 of those just in case that happens to you. There's a sort of a backup in case you sort of mess up the first one. That said, let's look at the wiring. So I've got all these wires here, and here's how it kind of works. So you can pop off the sheathing on the end here. It's been pre-cut and pre-stripped. This is the bare bone kit, comes included with that. The other ones I don't believe come with wires, but so here's how it'll go. We go short. There's a slightly shorter end and a slightly longer end. When you put them next to each other, it should be pretty obvious, but you know, it's not that huge of a difference. But the shorter end is designed to go into the circuit board. And so I'm going to actually stick those in. There's all of these places along the circuit board where there's a square hole and a circle hole. The square hole is the signal, and the circle hole is the ground, all the way across wherever it is. Well, in the power's case, I guess it's positive and ground. But the basic idea remains true. If it's audio, it's signal and ground. If it's a foot switch, which is controlling like the on-off function, there's ground, and then the signal, the voltage signal. Anyway, so I'm going to take the 2 shorter legs, I'm going to stick it into the circuit board like this, and then, and this might be a little bit hard to see, I'm going to slightly pull them up just enough so that when I push it down like this, there's metal exposed and I can solder from the top. If you've done the adjustment to give an air gap on this side, and you do that process I just said, it should lift up the metal sticking through. It won't stick through that circuit board so far as to short anything out, basically. So I'm going to do that all around the board. The exception is going to be on the foot switches. I am going to take the longer end, create a hook, and instead of putting these ones in the circuit board first, I'm going to stick them in the foot switches first. There's little lugs there I'm going to hook through and press those down. And so I'm going to continue and finish. I'm going to stop the video here, and I'm going to continue and finish this process. I'm going to show you what it looks like before and after soldering. So anyway, I'm going to go and do this process across the entire top, and then this process across all of these. And then there's the in and out jacks are here on the side, so you'll also see wires coming out of here when it's all done, and I show you what it looks like before soldering. Okay, so that's what I'm going to do, and I will be right back. All right, so I've stuck in the wires, but I haven't soldered them. I've got a row of seven pairs of 2, so 14 up there, and then I got the 3 foot switches, so 6 more wires there, and then the in and out jacks, 4 more wires there for a total of 24. Right now I just have this sort of gnawing thought that I might have included 22 wires in all of the kits, which if I did that, I'm sorry, I can't apparently count even though I'm a math teacher. I mean, this is just 24 gauge stranded pre-tinned wire. If you wanted to, if I did include less, or I mean, I'm willing to, if I did that, just let me know and I can ship you a couple extra wires. It's not a big deal. But if you didn't want to wait for that time to process or whatever, you could also just get 24 gauge wire and it's all good. All right, anyway, so I'm going to solder these all in on the top. I'm going to solder these into the foot switch. The other thing that I'm going to do is in this stage before I go to the next thing is I'm also going to solder into the, so after soldering in here, I'm going to actually during this stage solder into the power jack. So when I'm done here, everything will be soldered in on one side, but on the power jack it'll be soldered in on both sides because I can't put in the audio jacks until that's fully done. This is kind of my recommendation did. You can take a look at this kind of like way to lay the wires in such a way that you can solder it without things sort of like falling all apart. And so, yeah, I will solder that and get the next video going. All right, we are about ready for that last and final step of installing the audio jacks and doing the last bit of wiring with switches and such. So a couple of things here. So here's how I soldered in this power jack. You'll notice that none of the solder runs up the posts here into the black plastic part because I was wanting a good solder joint, but without getting anywhere near melting this black plastic, as I noted earlier. So I'm going to pull those legs up. I'm going to pull all of these legs down. And then up here, take the audio jack. It's got two lugs, and you'll notice that one is on the side, and then one's on the sort of like angled corner. The angled corner faces up and to the right, like so. And that's true everywhere. So here, all these 6, as you look at this one, it'll be up and to the right, the angled corner. As you look at this one, it'll be up and to the right as you're looking that same direction, relative direction here. You'll also be able to tell because as you look at the, well, it's harder to tell now that they're soldered, but so this is up and to the right here as I'm looking at the jack this way. This one is where the square lug is on the left, and this is the round one, which is the ground wire, and the ground wire is the one that is slanted. Okay, so one thing to note here is as you're sticking these ones in, they're going to, and see if I can make this clear, depending on how much you've angled this, they're going to be either right on the edge of flush with this board or slightly underneath the circuit board as far as pushed in. And again, depending on just small tolerances, there are these on the black plastic here, these sort of stick out just a little bit. There's these little, let's see if I can get it close enough. Where's the camera? All right. So these black plastic posts, hopefully it's refocusing. You can snap those off if it's not getting in there all the way. You can just take clippers and just clip them off if they're getting in the way of getting these all the way in. They're not vital to the support structure in any way, and so you can just do that. Okay, I'm going to pause the video here, and what I'm going to do is essentially I'm going to finish this thing. I'm going to finish all the soldering. Once you have this in, it's really easy. This wire goes to that lug, and this wire goes to the lug next to it, and then you've got 2 wires coming out here, and this one goes to the left, and the right one goes to the right, and so on all the way down. I would recommend soldering in. So for the, well, let me get an example I'll show you right now, and this will make a lot more sense. So if I stick this audio jack in right now, I've got the 2 wires here, and the left one would go to the left and the right one would go to the right. But as you can see, the place the foot switch solders in is underneath it in a really hard place. So I always, before I put in these lower 2 audio jacks, I solder in the foot switch wires, which those ones are the only ones across this whole thing where it doesn't matter which one goes into which. And so just the way that it sort of flows the best is the way that I do it. And so I just stick one wire of the foot switch into the square hole and the other one into the circle hole. And it'll say SW1, SW2, SW3 for the 3 switches. And right next to those things, oops, that's a little too far. This is why you use needle nose pliers. A little more precision there. Okay, I'm going to do it in such a way where I can go back in and solder into there. And so I'm going to solder those in, solder those in, solder those in. And then I'm going to come back through. I'm going to stick in all the audio jacks, and then I'm going to solder those wires. And then I'm going to show you what it looks like when it's all done, tell you what the internal controls do, and then give you some mod options. So that's the last of the video. All right. Okay, so there we go. There's the finished Klein Bottle. Not sure if it works yet. That'll be actually, there'll be a separate sort of video just to kind of walk through all the controls and how things work and all that kind of stuff. There already is one out from the prototype, and I'll make another one eventually. But that'll be for both builders and for people who just buy it off the shelf and want to start using it. So anyway, I want to let you know a little bit about some internal controls and some mods. So on the inside, you'll see 3 blue trim pots up in this upper section, and then 3 blue trim pots in the lower section. The 3 lower trim pots just adjust the brightness of their corresponding LED. So that trim pot, that LED. This is done for a couple of reasons. One, if you wanted to mix and match different colors, you could kind of get them to be the same relative brightness. And the other is that there is just naturally some variance or between brightness, and so I wanted to allow you to tune it. Also with preference, like some people like them really bright, and some people are like, no, that's blinding, make it dimmer, so you can do that yourself. These top ones are the pre-gain. So the circuit, what the circuit does is it comes in, it gets split, it gets buffered and then split between these 3 sections. It hits the base cut or the high pass filter first, which reduces a lot of the volume, especially if you use quite a bit of that. And then there's an internal pre-gain stage, and the gain of that section is set by this trim pot. And so it's set in such a way that that at 9 volts generally you don't get much distortion, but if you had a really hot signal or if you weren't cutting any bass whatsoever, it's possible that distortion would be added. In general, I recommend using 18 volts for this pedal, but that's not always practical. So I wanted to let you know that if you are getting unwanted distortion from the Klein Bottle itself, not from your other pedals, because you could push, using the pre-gain, push your other pedals into distortion. But this is, if it's from the Klein Bottle itself, you can reduce the gain on any of these channels here, or increase it if it's a really quiet signal. What was I going to say? Oh, as far as 18 volts. So if you're building this yourself, if all your capacitors are rated for 25 volts or higher, then great, you'll be able to use 18 volts. And all the parts that I've listed on the master sheet would allow you to use 18 volt power here, which would give you more clean headroom before distortion, use it with line level signals, those kinds of things. Also, if you were like using 18 volts here and you were using like a synth or whatever, you might want to reduce the pre-gain because the output volume is already pretty high, and you probably don't want to make it that much higher. Anyway, so that's what those are for. Some mods. Okay, so here's the deal. Like, if you want to change like the pre-gain range, I mean, that mod's already there basically. You know, mix level is from off to full. And then you've got these feedback controls, which you can, there is a place where if you want them to feedback faster, you can, but these things feedback pretty fast if you really crank it. So that's not really something that you really need to mod either. So the only thing that is really a mod to really change the pedal is these frequency ranges, whether you want to tighten them up to a specific frequency range, whether you want to extend that range higher or lower, or make it greater. And so I have currently in the documentation that I sent out, oh, where it is, oh, there we go. The full schematic, which looks like this, which if you print it on a sheet of paper, yeah, good luck trying to read that. But I also just did this, and I'll have this up soon, or emailed out soon, and linked in the description of this video. This is just one of the filter sections, and so there's 3 identical filter sections, and this one has the part numbers for this section. You'd have to refer to the, I wouldn't print it out, I would just look at the file and zoom in, because it's clear when you zoom in. The part numbers on here, but basically it goes like this. So in this schematic, here's a filter section. These are dual gang pots right here. These are the dual gang pots right here. And then this is the pre-gain. So it goes high pass filter or low cut, then pre-gain, then low pass filter, and then lastly, this is the output volume sent into the effects loop. Okay, so basically, if you want to shift the entire range of a filter up or down, you would just use the capacitors. Just change the value of the capacitors. So making a capacitor bigger, so making the capacitor larger will shift the frequency cutoff range lower. So bigger capacitor, lower frequencies. Same thing here. But what that ends up meaning is a bigger capacitor means more bass. And here a bigger capacitor means more treble cut, so less treble. So it, overall, the larger the capacitor, the more it shifts it down. The range is quite extensive, and so I don't think anyone really needs to do that, but I did want to let you know, if you are a more advanced user, you can do a little bit of math and figure this out. So this would set the overall range, and then this little resistor is essentially the limiter, and so it sets, so this first one here is a, I'm trying to remember, yeah, this is the 10K, C10K, and I think that's 100 or 143, now I'm totally forgetting, you'd have to look it up. Anyway, this sets the upper range, and this is when the full value added to this is the full range. And so if you know the formulas for a basic single pole passive high pass filter, you can do some of the math here and get the control to have the exact range you want it to be. Anyway, I just want to let you know that that's probably the only mod that, at least conceivably, as far as changing ranges of controls. Now you can obviously do things beyond that, but I'm not going to get into that. I've included the Eagle board and schematic files. So this is that schematic file, and then this is the board file, and you can obviously hide layers and stuff to sort of read where certain components are at and connected. But you can, if you really wanted to hack into it, you can look at this file and go, oh, I want to hack into this part of the signal, and you can cut a trace and all that. Now, I will note this is a 4-layer board, so there's some layers that are inside the board you can't have access to, you're not going to be able to cut. And you'll have to get creative if you need to somehow get access there. The other thing is that the circuit board itself, let me pull out one here, is thicker than a standard circuit board because it's 4 layers. I made it a little bit thicker to give some gap between all the different copper layers, so you don't have a crosstalk or signal bleed or whatever. Also, what was I trying to say? Well, it's gold plated to make it easier to do like mods and repairs. That's for the DIY builders. And then what's the other thing I was going to tell you? Oh, well, because it's a heavier, it's a 2-ounce copper instead of 1-ounce copper, and because it's 4 layers and all that kind of stuff. When you're doing your soldering, it's probably going to take you a little bit longer, and you're going to have to be a little bit better with your technique as far as heat transfer to heat up the solder joints to really let that solder flow. Because there's just more metal. There's just a lot more metal weight in this thing. But that also makes it easier to mod and repair, and a number of other things. Anyway, I think that's it. There'll be videos about how to actually use this thing and how it should actually work when you're there. Unfortunately, because I'm a teacher, if this doesn't work, I can't troubleshoot it for you. So that's, again, one of the reasons why I don't recommend this for a beginner, because I'm not going to be the one who's going to look at your build and figure out what's wrong with it. I just don't have that kind of time. So anyway, there you go. Enjoy. I look forward to hearing the sounds you make out of it. Thanks. Bye.